Good morning, students. This is Dr. Sharath Babu, your mathematics faculty, to teach the subject Mathematics 3. The Mathematics 3, we have discussed first 3 units in the class, regular class, that is partial differential equations and elimination of arbitrary constants to form the partial differential equations, and how to solve the partial differential equations, maybe linear or non-linear, and second order partial differential equations and their classification. They are broadly classified into 3 types. They are discussed, and their applications also we have seen. And in the third unit, we have discussed about normal distribution, uniform distribution, exponential distribution, Poisson distribution for a random variable capital X. It may be discrete or continuous. Now we are going to discuss about data dependent problems. What is meant by data dependent problems? A set of pair of values which doesn't have any relationship between them. So we have to construct a relationship between the dependent variable and the independent variable. Let us consider the process of constructing an approximate curve y is equal to f of x. We don't know the relationship between y and x, only we know the data points xi comma yi. I is equal to 1, 2, 3, like x1, y1, x2, y2, and n being the positive integer. So we have to construct a curve. Such curve is called curve fitting. Curve fitting and interpolation are closely associated procedures. What is interpolation? With the help of the data, we have to construct a function of the type y is equal to f of x. What is curve fitting? With the help of the data, we have to construct a curve which is close to the exact curve. This is called approximated curve. This is called exact curve, like this. This is an approximation in the interpolation. In the interpolation, we are using some the derivative concepts. Here also, we are using an important concept to calculate the process of curve fitting with the help of least squares, principles of least squares. In the least square, the given data is xi, yi. With the help of the given data, we can calculate into consideration the set of points xi, yi, x1, y1, x2, y2, etc. The points are there. Here it is. The points are here. See the curve. Once again, principle of least squares. In the least square, the set of data points are arranged here. P x1, y1, x2, y2, x3, y3, like so on, xn, yn. Actually, the exact curve is this one with the help of the data. This curve may be linear or non-linear. Linear or non-linear. If it is a linear curve, it is called a straight line. If it is non-linear curve, it is called parabola, ellipse, or power curve, geometric curve, exponential curve, etc. So first our focus on how to construct the curve. The data points are, n data points are given, and the distance between the exact value and the location, the point location is called error, E1. E1 is equal to the distance between P1, L1. And E2, second point is P2, X2, Y2. The distance is error, E2. If the point lies here, there is no error. Here the point lies below or above, there is a possibility of error. Error may be positive or negative, but the square of the error is always positive. That is, error is given by observed value minus expected value. What is observed value? The data given. Expected value means what? Actually, the value supposed to lie on the associated curve is called the expected value. The difference between them is called the error. E1, E2, like so, or En, like this. This is En. Right now. Means the point may lie above, the point may lie below. We don't know. Depends upon the curve nature. So this error, now in the least squares method, the author have taken the sum of the squares, E1 square plus E2 square plus like so on, En square. Let us consider E summation yi minus f of xi whole square. Now our main aim is to reduce this error. Once this reduce, capital E is reduced, automatically E1 square, E2 square like so on, En square also will be reduced, and vice versa, E1, E2 like so on, En are also reduced with the help of the least square. So what is reduced means what? The minimum value. Switch on the principle of minima or maxima. E possesses a minimum value, the first order partial derivatives with respect to the parameters. Here, the parameters are the variables. Variables are fixed here. So that dou E by dou A is equal to 0. Suppose my curve choice is y is equal to ax plus b. Suppose my curve choice is a straight line. Then the number of data points are n, and errors are, sum of the errors are, squares of the errors are capital E axi plus b. That is E yi minus axi plus b whole square. That must be minimized. So that what is the minimum principle? The first order partial derivatives with respect to the parameters a, b must be equals to 0. How many parameters are there? A, b. In our choice, it is straight line. There are two parameters are there. Dou E by dou A is equal to 0. Dou E by dou B is equal to 0. What is dou E by dou A? The square. This is, suppose this is capital Y, capital X whole square. Capital X square derivative 2x. 2 into x with respect to A. What is the coefficient of A? Minus AXI. Sorry, minus xi. That will be coming as a product. So after simplification, this will come as 2 is not equals to 0. So xi will come everywhere. Xi yi is equals to axi square multiply inside bxi. And similarly, with respect to b is concerned, the coefficient of b is how much? 1. The coefficient of b is how much? 1. The coefficient of a is how much? X. So the xi will come here. With respect to b, 1 will come here. The product. So finally, we'll get two equations of the type. The first equation, sigma y is equal to a sigma xi plus nb. How n is coming? Because b is coming at I is equal to 1, b is coming at I is equal to 2, b is coming at I is equal to n. So how many times b is coming exactly? Total number of times n times, nb. This is the first equation. Similarly, with respect to a, we are differentiated. That is sigma xi yi is equal to axi square. I am multiplying bxi. Xi, I is equal to 1 to n. Here the notation xy is written. Actually xi yi will be there. No problem. 3 and 4 are called normal equations of the given curve y is equal to ax plus b. I am repeating once again the process. Differentiate partially with respect to a and equate it to 0. These 3 and 4 are called the normal equations. These normal equations are concurrent. Concurrent in the sense that they must intersect. They must intersect at the mean value x bar comma y bar. That mean value will be calculated with the help of the data. What are the data is required? Sum of the y values, sum of the x values, sum of the product of xy values, and squares of some x values and sum of the x values. Depends upon the normal equations, we construct the table. Here the table contains what? Sum of x values, sum of y values, sum of xy product, x square sum, and sum of x is already here, it is there. So in example 1, by the method of least square, the data is given. How many paired values? 1, 2, 3, 4, 5 paired values. N is equal to 5. Take n is equal to 5. And construct the normal equations as it is. Sigma y is equal to sigma x plus nb. I want to calculate ab values. We want to calculate those values. Now, what are the tools are required here? The statistical data sigma x, sigma y, sigma xy, sigma x square are required. Calculate. Substitute in the equation. Those 4 5 equations are called normal equations. They are concurrent. So let's solve those normal equations. Get the values a comma b values. A is equal to 1.9, b is equal to 1. Substitute in the equation. The best fit is y is equal to a plus bx. A plus bx. A is equal to 1.9, b is equal to 1, etc. Like this. And here the relation in example number 3. F is the force required to lift a load W by means of a pulley. Fit a linear expression. The interest is what? FW values are given, and A comma B values are to be calculated. Construct the normal equation. Sigma F is equal. N is equal to how much here? N is equal to 1, 2, 3, 4. N is equal to 4. Construct the normal equations and construct the required statistical table data. W, sum of W value, sum of F value, sum of WF, like X, instead of XY, WF is given here. W square, calculate those values, substitute in the normal equation, get it. And in the fitting of a parabola, this is also similar to the straight line. Here, Parabola means what? Any second degree polynomial is called a parabola. Ax square plus bx plus c, ABC values are required. With the same guidelines, with the help of the least squares method, what is that? The error E capital E is equal yi minus f of xi. Yi minus f of xi. Yi is called observed value. F of xi is called the expected value. Expected means what? We are expecting some value, exact value. That exact value is close to observed value. If observed value and expected value both are the same, there is no error, but there is a possibility of error in any data. That is EI. So according to least squares method, capital E is equal to sum of the squares of the all possible errors that should be minimized with respect to the parameters. Dou E by dou A must be equated to 0, dou E by dou B is equal to 0, dou E by dou C is equal to 0. And dou E by dou A is equal to 0. What is the coefficient of A? Xi square. Xi square everywhere will come as a product yi xi square, a xi square into xi square, xi power 4, bxi into xi square, xi cube plus cxi square. That is the first equation you are going to get. That is xi square everywhere will come. That is written last way. And with respect to b, what is the coefficient of b? Xi will come everywhere. If xi is coming everywhere as a product, neither sides. What is the derivative of this actually? 2x into xi product. B product is how much? The coefficient of b, subject to correction, the product of the coefficient of b is xi, multiply here xi yi is equal to a xi cube plus b xi square plus c xi. Here it is equation number 2. In the reverse order is written. Dou E by dou A is equal to 0 with respect to A, the last equation. Dou E by dou B is the center equation. Dou E by dou C is the first equation because the C coefficient is 1. So that simply sigma yi is equal to a sigma xi square plus b sigma xi plus c is coming how many times? N times. Sigma c. Sigma c means what? C plus c how many times? N times. Nc. These are the normal equations, 3 normal equations. Why 3 normal equations are coming? Because there are 3 parameters are involved. Solve these normal equations. In order to solve the normal equations, we need the statistical data like sum of the y quantity, sum of the x square quantity, x quantity, product of xy, sum of x cubes, sum of x square, and x square y quantity, sum of x4, 4, x cube, x square. Accordingly, we have to, according to the normal equations, we prepare the data. We must prepare the data. xy, x square. Now, 2, 3, 4 are very, very important. To get 2, 3, 4 correct, your data should be correct. Some values. Right now. Scientific calculator is available in the examination. You can take scientific calculator, sum them, calculate them, get ABC values. 3 normal equations. 3 equations you will get in terms of ABC. In mathematics, that is scientific calculator, equations, 3 unknowns. Give the A values coefficient 1398, 80, 5, 100. Next, 26270, 1398, 80, 1684, 52120, 26270, 1398, and 30648. Just if you give the values, we will get XYZ values will come. But instead of XYZ, ABC are sitting. So that copy those values, ABC values will get. Similarly, parabola, one more example is also there. The same guidelines. Change of scale, you don't worry about change of scale. If you are interested, you can go through it. Otherwise, you follow the method we are discussing. It is not required actually change of scale according to our syllabus. Just you follow that method. Correlation. What is correlation? There are 2 variables are there. 2 variables are how they are related. The relationship between 2 variables is called correlation. So see the tendency of the graph, it is increasing up direction. It is called positive correlation. The tendency is decreasing, it is negative correlation. And there is no correlation, 0 correlation. There is no correlation because some of the values are ascending, some of the values are descending. The example of 0 correlation, positive correlation, negative correlation. It all depends upon the curve nature. Correlation is a measure of association between 2 variables which may be dependent or independent. Whenever 2 variables extend are so related that increase in one are accomplished by an increase or decrease in the other. For example, if you are traveling in a train, the best example is if you are traveling in a train, the distance of your destination is increasing, the fare of the traveling charge is also increasing. Its tendency is positive correlation. Suppose your age is increasing, automatically your IQ power is decreasing, is called a negative correlation. Especially in the old age people, IQ is decreasing. Means in the positive correlation, both are ascending. In the negative correlation, one is X is ascending, Y is descending, vice versa. Example, atmospheric pressure and voltage are negative. Once pressure is increasing, what is the voltage? PV is equal to constant. Value is decreasing. They are inversely correlated. And how to calculate the relationship between those two variables? There is a numerical calculation is called coefficient of correlation. Coefficient of correlation R, which lies between -1 to +1, both are included. This R value is 0, then I can say there is no correlation between two variables, independent and dependent. If it is positive correlation, it lies between 0 and 1. One is also considered. When it is negative correlation, it lies between -1 to 0. So Karl Pearson is a statistician who investigated to calculate the correlation of coefficient. Coefficient of correlation between two variables x and y is defined as R is equal to covariance of xy by root over variance of x, variance of y. What is variance of x? Dx, x minus x bar. X bar is the mean of x series, y bar is the mean of y series. Mean, how to calculate mean? Sum of the y quantities by total number of observations. And the standard deviation is given by root over sigma dx square by n. Dx value is here, it is. You can calculate sigma x, sigma y. Sigma x is called the standard deviation. And covariance of xy is equal to sigma dx dy by n. This formula is simple. So calculate these values, get the R value. Some of the examples are given. Calculate coefficient of correlation from the following data. Data is available. Sigma dx dy. What is dx? X minus a. First calculate the x bar. X bar is equal to how much? 5. How x bar? 1, 2, 3, 4, 5, 6, 7, 8, 9 observations are there. Sum them. Sigma x is equal to 45. 45 by 9. 5. X minus x bar. X minus x bar. X I know. X bar I know. X minus x bar. 9 minus 5. 8 minus 5. 7 minus 5. 6 minus 5. 5 minus 5. 4 minus 5. 3 minus 5. 2 minus 5. 1 minus 5, etc. Once dx I know, dx square I can calculate. Y series is given. Calculate y bar also. Y bar is what? Mean of y. Y bar, some of the quantities, some of the y series values, 108 by 9, 9 12s are. 12 lines are 108. 12 into 9. Y minus y bar. So d sigma dx dy. How dx dy is coming? Sigma dx dy. Product them. Dx dy. Dx dy. Dx is equal to how much? 4. Dy is equal to how much? 3. 4 into 3, 12. 3 into 4, 12. 2 into 2, 4. 1 into 1, 1. 0, 0, 4, 12, 12, etc. Sum them, substitute in the formula. You can use any formula to get the correlation. Some of the examples are narrated here. Bivariate is not there in our syllabus. This is the 4.42 is not there in our syllabus. Don't worry. Leave 4.4.2 is not there in our syllabus. Coefficient of correlation by rank differences, that is called rank correlation coefficient. Spearman's rank correlation formula is given by 1 minus sigma 6 sigma d square by n into n square minus 1. D is equal to R1 minus R2. So rank means what? According to the merit of the student or merit of the quantity of your product, ranks will be decided. If there is a tied ranks are there, if two or more observed in a class, we can see there are two students are obtaining the same equal marks, is called a tied rank. They will be awarded as a same rank. But here, when ranks are tied, then correction factor can be calculated by sigma m into m square minus 1. Whenever this correction factor, we are using the correction factor whenever there is a ties in ranks, otherwise leave it. So the value Spearman's, whenever ties are there, add the correction factor 1 by 12 into CF. CF stands for correction factor. Here rank in English, suppose example, calculate the coefficient of correlation from the following data, given ranks of 10 students in English and mathematics. Correlation. And afterwards, rank correlation. This is rank correlation. Actually, rank term is missed. Whenever this formula is using Spearman rank correlation, rank is missed. Calculate the rank correlation coefficient. General correlation coefficient above we are discussed with the help of what? Deviations only. But here ranks we will be considering. D. In the above correlation, ranks are not considered. Here ranks are considered. This is a rank correlation coefficient. So rank correlation coefficient means what? Spearman's rank correlation we have to apply. The above only correlation we have discussed. So ranks given R1, R2, English, 3, 1, 5, 4, 2, 6, 8, 10, 9, 7. The same order, difference, sigma d square. This is. And 8 competitors in a beauty contest got marks out of 10 by 3 judges as given. Beauty in the contest, Judge A, Judge B, Judge C are given the marks. If there is any tie, there is no tie at all. So that difference of AB, difference of BC, difference of AC will be considered right now. More number of persons are there. Then rank correlation between A and B. You can calculate with the same help of the formula. Rank correlation between B and C and A and C. Means after calculating this, difference of AB, difference of BC, difference of AC. There is no tied ranks. Once tied rank is there, correction factor will come. Here in the example 14, there is a tied rank 2020, and in the Y series also 1616 is coming as a tied rank. So then the order 20, 24, 12, 20 is coming twice, right? So correction factor 20 is coming twice, 2 into 2 square minus 1, and the other numbers are coming 3 times. All the values will be considered. X, Rx, Ry, ranks accordingly we will be. So you see the X series data. The X series data 24 is the highest. So 24 is the again 24 is coming. 1, 2 ranks are there actually. Average of 1, 2 is how much? 1.5. So 1, 2 ranks will be distributed to 1.5, 1.5. Next rank will be 3. Third rank is there. So third rank again. The third rank 1.5, 1.5, next 4th, 5th, etc. The ranks will be distributed like this. Then Y series, first rank, second and third rank is sharing, and 4th, 5th, 6th are sharing here, 5.5, 5.5, etc. Then calculate the differences, sigma d square. And in the correction factor, how many times the rank is repeated, data value is repeated, count it. If value is repeated 2 times, 2 into 2 square minus 1, other value is repeated 3 times, 3 into 3 square minus 1, like that we have to calculate. So I think here 1, 2, 3, 1, 2, 3, 4, the ranks are repeated, some of the values. So the correction factor, once again verify the correction factor. The X series, the data 1.5, 1.5, 1, 2 common ranks are there. Next, third rank, third rank is given as 4, 4. The next, fifth rank is there. So fifth and sixth, 5, 6.5, 6.5, like that. 6, 7 up to completed. Next, eighth rank. Like that we have to give. While giving the ranks, this is the hierarchy we have to follow. 1.5, 1.5, 1, 2, 3. Next, third rank, commonly 4, 4, 4, 4 is coming. So 3, 4, 5 completed. Next, sixth rank again, 6, 7 shared by 12 number. 7 up to 7 completed. 10, it is 8th rank. Observe the logic. First rank, 24, 24, 1 plus 2, 1.5, 1.5. Third rank, 20, 20, 23, 4, 5. 3, 4, 5 average is what? 4. 4, 4, 4 we have to give. Next, fifth rank is concerned, 6.5, 6.5. So 12, 12, sixth rank. So 5 plus 6 plus 7, that is 6.5, 6.5. 6, 7 ranks are completed. Next, the highest, lowest number is what? 10. 10 is only one time, it is 8th rank. Count here 1, 2, 3, 4, 5, 6, 7, 8. This is the way we have to give the ranks when repeated ranks are there. In Y series also you can observe 22 is the maximum 1 and 2.5 is awkward with 19 because 19 is repeated twice, 2.5. Next rank will be 2, 3 is over, 4, 5, 6. 4, 5, 6 is given to 16. 16 is repeated how many times? Thrice. 16, 16 twice. So 4, 5, 6, 5.5. Next rank is up to 6th rank, 7th rank is 7th is 14. 14 is taken 7th rank, 12 is taken 8th rank. Like that we have to give the numbers here. The logic you understand first at the time of repeated ranks is very important. Then substitute the formula, get the rank correlation. Regression. The next concept is regression. There is a slight deviation between correlation and regression. Regression describes the functional relationship. Only we have to calculate the relation between two variables. How they are varying, why they are varying, we least bother about it. The correlation, how they are varying, it is they are varying positively, negatively, or up direction, low direction, etc. We are considered depends upon the what is the correlation coefficient. The regression it is a relationship between independent variable and dependent variable, which helps us to make estimates of one variable from the other. If I know y is equal to f of x relation, at x is equal to x naught, what is the y value? That is regression between the two variables. Whereas linear regression finds the best line that predicts y from x and also x from y. X from y is concerned x being the dependent variable, y being the independent variable. Y from x is considered y being the dependent variable, x is the independent variable. Once if I know independent variable value, then I can predict the dependent variable very easily. So lines of regression are nothing but the normal equations of x and y, a plus bx, right? Normal equations that is discussed in least squares. Then these normal equations are concurrent. They are passes through the mean x bar and y bar. X bar and y bar are means of x series and y series. This shows that x bar y bar lies on the line, so they are concurrent. So that solve these two equations 2, 3 to get AB values, A comma B values. So once I know A comma B values, again there is a possibility of getting rank or is equal to rank correlation coefficient. What is sigma x? The standard deviation of x series. Sigma y, the standard deviation of y series. And sum of the deviations of x minus x bar is equal to 0. To verify for any data, x minus x bar is always 0. X minus x bar, the value will be 0. So that you can calculate, and this value is very important. B value r into sigma y by sigma x. You have to remember this value. And byx is called the regression coefficient y on x. Byx denotes slope of line of regression line of y on x. Byx. So byx is considered r sigma y by sigma x. Just you remember this formula. Once you remember this formula, sigma y how to calculate? Here it is there. Sigma x also is defined. With the help of this, you can calculate. And the relationship between correlation coefficient and the regression coefficients are given by r is equal to root over bxy into byx, right? And bxy plus byx by to the arithmetic mean is always greater than or equal to geometric mean. It's a relation from data series is equal to r. Arithmetic mean of the two regression coefficients is greater than or equal to the correlation coefficient. Just remember this formula. Prove that the arithmetic mean of correlation coefficients of regression is greater than the coefficient of correlation. R value is given bx by byx. So first half into multiply, take half outside, or sigma yx, associated formulas, sigma x square plus sigma y square, sigma x sigma y. This value is greater than 0. This is a plus b, a minus b whole square. The absolute value of a minus b whole square greater than 0. Arithmetic mean is equal to r if bxy is equal to byx, that is r is equal plus or minus 1. Or maximum value is plus or minus. Minimum value is minus 1, maximum value is plus 1. In the formula you have to remember, theta be the acute angle between the two regression lines for two variables x and y, then tan theta is equal to 1 minus r square by r into sigma x sigma y by sigma x square plus sigma y square. And y on x equation you have to remember. This is the way we have to write y on x regression line. Y minus y bar is equal r sigma y by sigma x into x minus x bar. Y on x. Y on x, always x is sitting at the bottom. X on y, y is always sitting at the bottom. That way you logically have to remember. And tan theta is equal to how much? M2 minus M1. Here M2, y minus y1 is equal to M into x. This is M, M1. This is M2. M1, M2 are known values. This is b by x. This is bxy. X. Writing x as y, bxy. Writing y as a function of x, byx. This is bxy. Those values substitute M1, M2 values in tan theta. Then 1 minus r square by r, sigma x square plus sigma y square. And the tendency is when r is equal to 0, something by 0 is infinitive. Tan theta is infinitive, theta is equal to how much? Pi by 2. When r is equal to 0, what happens? The two lines of regression are perpendicular because theta is equal to pi by 2. When r is equal to plus r minus 1, tan theta is equal to 0. R is equal to 1, tan theta is equal to 0. It's visible. Means they are parallel. The two lines of regressions are coincident, the same. And example 17, find the correlation coefficient between x and y. In the two lines of regressions, regression lines are given by. So how to calculate regression correlation coefficient? I want the regression coefficient, bx by byx. Let the line of regression of x on y. You select one is x on y, another one is y on x. That is your choice. The first equation I am considering x on y. So write in terms of x this one. Second one in terms of y. So write in terms of x, first one, what happens? X is equal to 9 by 2 y minus 3. So what is bxy? The coefficient, this one, bxy, xy, 9 by 2. And second equation, try to write y in terms of x. That is, choice is yours. We can select in any way. This is x on y. Suppose you are taking this is x on y, this is y on x. And vice versa, no problem. And our value is given by what? Root over byx into byx. Bxy into byx. Already 9 by 2 into 1 by 2, 3 by 2. So how much? Root 3 by 2. Root over 3 by 2 is how much? So our choice of regression lines is incorrect because our value is always lies between minus 1 to plus 1. So this first equation, our choice is wrong right now because our value will be satisfied between minus 1 to plus 1. So first equation consider as y on x. Earlier we have taken x on y. This is y on x. So automatically the second equation will be x on y. That way the slopes will be changed. The regression coefficients will be changed. R value will be 2 by 3. So 2 by 3 value is 0.66, slice between minus 1 to plus 1. In our earlier choice, it is crossed the limits 3 by 2, 1.5. It is not in the range minus 1 to plus 1. This range is not there. Similarly, the regression equations calculated from a given set of observations. This problem is important. Most of the time, this example later is asking x is equal to minus 0.4y. Calculate x bar and y bar. What is x bar comma y bar? X bar comma y bar are the mean values of x series and y series. There is a principle that the regression lines are always passes through the mean values of x and y. Means what? The intersection point is nothing but x bar comma y bar. So if I want x bar comma y bar, just solve these two equations. Dxy, dyx you calculate and r value. Right? He is asked in the question. Regression equations calculate from the given x bar and y bar and r is also asked. R value how to calculate? R is equal to root over byx into bxy. So r is equal to minus 0.49. Both bxy and byx are negative. R must be negative. If bxy, byx both are positive. R must be positive. Accordingly, you have to consider. So bxy, byx both are negative. Then r value will be negative, like that. Again, we know that the point of intersection of two regression lines, x bar comma y bar are nothing but the intersection points of 1 and 2. Because the two regression lines must intersect at the point, the mean values of x series and y series, x bar comma y bar. X bar comma y bar is nothing but the solution of 1 and 2, where 1 and 2 are the regression lines. Similarly, 19, you can see calculate byx, dxy similar. X series and y series, and here also following data depicts the statistical values of rainfall and production of weather in a region for a specified time period. Mean value, standard deviation is given. Mean value, standard deviation. Estimate the production of wheat when rainfall is 9 centimeters if correlation coefficient between production and rainfall is given to be 0.5. Given that x bar according to the table, x bar is equal to 10, y bar is equal to 8, sigma x is equal to 8, sigma y is equal to 8. What is sigma x? The standard deviation of x series, sigma y, the standard deviation of y series. Now, construct the regression equation x on y, x minus x bar is equal or sigma x sigma y by y minus y bar. When rainfall is 9 centimeters, production of wheat is estimated to be 2 into 9 minus 6, 12 kgs per unit area. Because x on y, why we are writing x on y is given product of wheat, kg per unit area and rainfall both are given. Estimate the product of wheat is asked. Product of wheat means what? X we are taking, that is, and rainfall is y. Okay. X is x and y denote production and rainfall. X is nothing but production and rainfall. So accordingly, you can calculate x on y equation so that once y is 9 centimeters, automatically we can calculate estimate x value. Rainfall is 9 centimeters. Production of wheat is estimated to be 12 kg. Similarly, in example 22, coefficient of correlation, some data is given, sigma x, sigma y, etc., x bar, y bar, and with the help of that, we can calculate sigma x square, sigma y square, R value, another formula for correlation coefficient. This is important formula, sigma x by sigma x, sigma y by n. Alternate, there are plenty of formulas are there. This is also very important formula. You highlight this formula, this simple formula, to calculate the coefficient of correlation, 0.57. Once you know sigma x, sigma y, and R, bxy, that is the regression line xy, bxy means what? The regression line x on y, slope, bxy is equal to R sigma x by sigma y, and byx is equal to 0.7. Equation of lines of regression are y minus y bar is equal to byx. Byx just now we are calculated, substitute, y bar x bar also calculated, so that we can get y value as well as x value. So the important thing is which one is x on y, which one is y on x, I said already, depends upon the values of byx and bxy, which satisfies bxy into byx is equal to r. R must be lies between -1 to +1. Both are included. That point must be noted. R lies between -1 to +1. And whatever the bxy, byx signs are there, R value will be the same sign. Bxy, that is the slope of x on y, slope of y on x, both are positive. R is also positive. The coefficient of correlation and the coefficient of regression are having the same signs. That concept you have to remember. That is the basic concept of regression coefficients and correlation coefficient. Similarly, some of the examples are narrated. X bar and calculated R values. Some of the exercise problems are also given, and bivariate is not there. Bivariate correlation coefficient is not there only, and answers are also given for your easy reference. Answers are also there. In this class, we have discussed how to construct the normal equations with the help of the least squares method. In the least squares method, our aim is to minimize the error. What is error? The difference between observed values and expected values, yi, f of x. So construct the normal equations. Suppose there are some other equations are also there. Y is equal to a into x power b, power curve, x power b. Take logarithm both sides. Log y is equal log a plus b log x. So log y is equal to capital Y, log x is equal to capital X. That equation will be once again linearized. Then again apply the least squares method. That kind of equations I will show in the next class. And here, what is correlation? What is regression? What is rank correlation also we are discussed in this class. This is the part of unit 4. Thank you, students.